Okay, what I thought I would do is put together just a quick video to show you the data processing, the way it's set up right now. This all can change, but hopefully this will give a sense of how the data look and some things that we can do, and maybe some things we need to do as we record the data in the future. So let me go to the program, and I think I'm just going to share that. And I use MATLAB to process data. I get the data from the program in a CSV format, and then read that into the program and do some processing with it. And I can explain that here. Easy if I just run the program. Oh, you'll see the first error. Oh, that's okay, because I typed in the wrong program. And what's going to happen, it's going to read in the file from the MileTech shorts, and that file contains EMG data from the different muscles. And so what I have here, you're going to see this over and over again. On the top plot is the quadricep muscle, and the two lines are right and left. And off the top of my head, I'm drawing a blank on which color is which, but you'll see that as we go along. Then the next plot is the hamstring muscle, and again, right and left. And then the final plot is the gluteus maximus, again, right and left. And this is the, when I have an underscore in the name of the title, it does this subscript. So down here, this is 6/27. That was the date we did the test. And this is the jump test. So this is just doing the vertical jumping, and there was no activity other than just jumping. Now realize that sequencing wise, we did this after doing some other things, but I put this one first just to start off with a basic jump up and down on the trampoline. So what I need to do for the program is, the instructions are down here. Click at the beginning of the quadricep data to be extracted. And I could choose any muscle, but what I decided after looking through the files is to identify a peak activity in the quadriceps. Again, we could do any muscle, but I thought I'd start with the quadriceps, and then identify that point, and then extract all the data between this point and then the next one. So down here it says click at the end of the quadricep data to be extracted. So I'm going to click on this one. Why this one? I don't know yet, other than I want to avoid some of the beginning and the ending jumps that maybe the data collection started, and the person, in this case, Scott, was doing some jumps, but wasn't quite in the rhythm yet. And same thing at the end, maybe something odd happened near the end, like this one here. Maybe we're catching the stop of the jump. Now, why there's this difference here, I don't know. That seems to be a very asymmetrical firing of the gluteus maximus. So I'm going to click this one here. And what the program does, I'll have to build in a step that shows that a little better. It extracts the data between those two places that I clicked, and I only analyze the data in those two places. And time was on the x-axis. Sorry, I don't think I noticed. I noted that. So now this plot comes up. This is the same file, the jump test. And on here is the left hamstring, and on here on the x-axis is the left quadricep. So now I'm taking the two muscles that are on opposite sides of the thigh, the anterior and the posterior aspect, and I'm plotting them next to each other. My hope was that there would be some coordination pattern that would start showing up through these different movements. And along the way, I also processed the data a little bit. I smoothed it just to get some sort of a cleaner signal, and I can explain that in more detail. So this is the hamstring and quad, the left side, and then this is the right side, right ham, right quad. I didn't do the glute because I didn't have another pair for it, but what we could do is any combination of muscle. So we could do right quad, left quad on each axis. We could do right ham, right glute, left glute, anything like that. Or we could do the gluteus, right glute versus the right hamstring. Whichever way we want to do it. I just started with this to generate some ideas and some discussion. And as we do this, we can start looking for patterns and seeing if there is any value in this. We did this with running in the water, and we looked at, in essence, this ends up representing a coordination between muscles firing. Nothing really jumps out at me with either of these plots, so it's a little disappointing, but it's at least a place to start. Okay, I'm going to hit the program, tell the program to continue, and now the next, which is actually the very first activity that we did, next file comes up. So this is back bouncing from dead bug position, relaxed. And again, what I'll do is extract data from this peak. And again, why this peak? Just trying to avoid the beginning and ending portions of the routine. And then here, I'm just clicking that, and then the data would be extracted. And now we have the muscle plots again. So this is left ham, left quad, right ham, right quad. I advance. This is the back bouncing from dead bug position. I don't know what this is, but you folks do. And again, I'm just going to pick out a peak here and a peak here. We could redo this. This is easy to do, but I'm just extracting the data between those 2 points. I'm actually also calculating some average EMG and some root mean square EMG between these 2 points. That's a funny muscle pattern. This is funny that this is coming out. This is just indicative of one of the jumps was just different than all the other jumps, but clearly there's something concentrated in this area here. And this is the jump test alternating turn. And when we meet, we can go through this in more detail and look at this a little closer. I don't know if something's jumping out here. What would be an advantage is that actually have a longer file, if that's possible. You guys know the routine, whether or not that makes sense. But the more repetitions we get, the more this plot may actually settle on some pattern that we can pick up. Oh, those are the only ones I did for this. And how many did I do here? I did 4 files, but we actually have far more than that. Let me just look quickly, because maybe I can go back and run them again. I get all these output files that I generate as well. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so let me go back and change this to 11. And I will just continue this. So let me change this to 11. And I have to start from the beginning again. So you're just going to see the repeat of the first 4 files. So this is the jump test. And I'm just picking, at this point, I'm just picking sections that I think are reasonable. Some pattern. And again, I'm using the quadriceps. There's no reason why we can't zero in on another muscle to extract the data. I'm just using that because I don't have any other kinematic marker at this point. When we get the shirt in, which hopefully is coming in soon, the shirt can give us some kinematic data that we can actually try to use to identify start and stop places instead of this in terms of using muscle. Okay, so now we are jump test left 1/2 turn. I'll just go here to here. And then this is jump test, no ceiling. Oh, I think the first one we did, Scott, you were hitting the ceiling. So now this is no ceiling. There's that asymmetry here again. I don't know what's going on there, but it looks like you're using one side more than the other. Okay, so let's remember green is higher than red. I'll look at the program to see which side is which, and I can add that to the figure too. This is jump test right 1/2 turn. Just selecting those. Again, this is just to start trying to get an idea in terms of muscle coordination. Jump test, straddle, tuck, pike, relaxed. I don't know, this might be really important to make sure we're getting the right start point. This might be, this file is mixed with it looks like 3 different maneuvers. So I'm going to start closer to the beginning here. And ideally, we do have some video, but our shirt will actually give us some kinematic data that would be similar to video. Oh, that's interesting. It's more concentrated there. Jump test, straddle, tuck, pike. And there is, different peaks here based upon which side we're dealing with. So I think that is the red is the right side. So that means your green, your left side is showing up higher. Okay, now this starts to show what I would start looking for in terms of coordination pattern here. This starts to settle in. And what this actually tells us is the quadriceps is firing while the hamstring is quiet predominantly. So this is a predominant quad exercise and not much happening with the hamstring. This is showing that a little bit, but it's also showing some hamstring firing while there's also some quadricep firing. This is wall run, trampoline long position. Again, I don't know where to start at this point. This would be something we'll need to do a better job of as we collect data the next time. And I'm going to include that funny green glute down there. And again, this is interesting. Lots of quad activity. Well, I guess maybe that makes sense. I mean, how active would the hamstrings be? But this is clearly a dominant for the quadriceps, and even this. So this is showing that quadricep activity is increasing, it's decreasing, while very little change in hamstring activity. Wall run, trampoline short position. Choose that one, that one. And, trampoline being largely a knee extensor activity, that's not going to be too surprising. But your hamstring does also do hip extension, which will be happening here as well. So maybe some of this is really showing is more related to hip extension happening due to the hamstring firing. I guess that tells me where I need to add in the glutes as well. Okay, so that's the program. And let me just quickly see if I can see my plot here. I will double check the color of the sorry here. Oh, circus plot. I did a whole nother program for that. And green is left and red is right. Okay, so that's a little bit of the processing for EMG or using these shorts. And hopefully this continues our discussion about some of the things that we can do. And we can talk in more detail when we meet online, and we go through the program again as well. All right, thanks, guys.